I think we're ready to talk about the area of a triangle now. Let's begin by just drawing a triangle. You can label it A, B, C. So the sides are C, A, and B. We should know, I believe, that if we were to drop straight down here and call this H, the height, and this forms a right angle here, the area of this triangle is equal to 1/2 the base times the height, or 1/2 the base is B in this picture and the height is H. Okay, well that's great, and it works very well if you're able, or if you know the height of this triangle. If it's a right triangle, of course, then maybe you know the height of the triangle too, or you can find it with Pythagorean's theorem. But supposing you don't know that, and all you know is information about the stuff on the outside of the triangle. So how can we find the area of this triangle? And so what I'm going to do is show you that if we look at this right triangle, okay, in this right triangle, the sine of angle A is equal to the opposite H, or the hypotenuse C. So H is equal to C sine A. Okay, let's pull that substitution there. The area of the triangle becomes 1/2 B C sine A. So in other words, if we know two sides, okay, BC, and the angle between those two sides, A, hence we know side angle side, then we can find the area of any triangle. Okay, so again, I don't really memorize the formula BC sine A because I think I remember like letters. I just know looking for any two sides, angle between them. Any two sides, angle between them. This will calculate the area of the triangle. Okay, the example here, find the area of the triangle. Draw a picture if you want, if you feel that it's necessary. If this is angle A and it measures 52 degrees, that means this is side A. This can be B, which makes this little b. This would then be C, which makes this little c. If you draw it out, then maybe it's easy to see that yes, in fact, we do have two sides and the angle between those two sides, which is exactly what we need to find the area of the triangle. It is 1/2 times the side times the side times the sine of the angle between them. So I'll calculate at work. The area of this triangle is 115.84 units are, looks like meters squared. The other triangle area formula that we have is one in which we're giving a side case. If we know all three sides of a triangle, so say we know this is side A, we know side B, we know side C, we know all three sides. The area of this triangle is found this way. It is S times quantity S minus A times quantity S minus B times quantity S minus C, where S is equal to A plus B plus C divided by 2. This formula is called Herons Formula. Okay, so you have to know all three sides, and if you know all three sides, then you can use them to find this S value. This S is called the semi-perimeter and you plug all the numbers, the S, the A, B, C in, and you can work out the area. Quite possibly in class I may show kind of the proof of this, kind of where this formula comes from, but for the sake of the video and keeping it short, I'm just going to give it to you and then we'll practice it with a couple of problems. Okay, find the area of the triangle. We've got 3 sides. Okay, so we're going to use Herons Formula to do this. In order to use Herons Formula, we need to find that semi-perimeter first, which is the sum of the sides divided by 2. So let's see, 23 plus 19 plus 12 divided by 2 is 27. So the area of this triangle is 27 times 27 minus 23, 27 minus 19, 27 minus 12. So it's the square root of 27 times 4 times 8 times 15. I want the square root of that number. So the area is 113.84. No units given, so maybe I just do that. Square units. Last problem I have says find the area of a regular nonagon, and if we don't know what a nonagon is, it's one that has 9 sides. Regular means all the sides are congruent, all the angles are congruent, inscribed in a circle of radius 10 inches. So let's see how close we can get to drawing a circle here. Okay, maybe something like that. I am not going to try and draw a nonagon inside this circle, but a nonagon, so it has 9 sides. So we would have, draw, points on the edge of the circle where you would connect points, etc., all the way around the circle. Maybe we'll try and fill this in. That's 3 sides. 4, 5, 6, 7, 8, 9. So there's 9 sides. Of course, it's not beautiful. It's not easy to draw. But we want to find the area of that figure. To find the area of that figure, what I'm going to attempt to do is find the area of one of the triangles formed. There are, of course, 9 of these triangles, as it's a nonagon, but if we can find the area of one of them, then we could take it times 9 and we have the area of the whole thing. So let's just look at one of these triangle wedges. This is length 10 and 10 because that's the radius of the circle. The angle on the inside would be the entire circle, 360 divided by 9. So the angle here is 40 degrees. And so what we're looking at is a side angle side situation. The area of this triangle is equal to half times 10 times 10 times the sine of 40 degrees. Okay, so the area of this triangle is equal to 32.13938, etc. There are 9 of these triangles. So the area of this regular nonagon is 289.25 inches squared.